Hi students, in today's session I am going to teach you about molecular orbital theory for 1, 3, 5 hexatriene and benzene. MOT for 1, 3, 5 hexatriene and benzene. What is 1, 3, 5 hexatriene? Let's see the structure of 1, 3, 5 hexatriene. See, hexa means 6. 1, 2, 3, 4, 5, 6. Triene. Triple double bonds are present in this structure. The triple double bonds are present at first place, third place and fifth place. Hexa means 6. Tri means 3 double bonds. Where those 3 double bonds are present? First carbon, third carbon and fifth carbon. First carbon on double bond and third carbon another double bond and fifth carbon is another double bond. 1, 3, 5 hexatriene. Hexatriene. 3 triple bonds are there. Means these 6 carbon atoms in this structure are in sp2 hybridization. In sp2 hybridization. All carbons are in sp2 hybridization. Means that each and every carbon are having a pi bond. Means 1, 2, 3, 4, 5, 6. 6 are having one unhybridized p orbital. One unhybridized p orbital are present in those 6 carbon atoms. sp2 hybrid. Remaining are hydrogens. So now carbon atom are having 4 bonds around each. See, these 2 bonds are forming double bond, these 2 are double bond, these 2 are double bond. That is the structure of hexatriene. CH2, CH, 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 CH. 4 bonds are there. Now we are going to focus only on these unhybridized p orbitals which are forming pi bond. That is our motive. That's why we are studying pi molecular orbital theory for 1, 3, 5 hexatriene. So now these 3 means 6 unhybridized p orbitals are there. So that 6 molecular orbitals will be generated. Those 6 are 1, first one is psi 1, second one is psi 2, third one is psi 3, 6. So 6 molecular orbitals will be generated. Those 6 molecular orbitals I am drawing. Next one is psi 4, psi 5, and psi 6. Among these 6 molecular orbitals, 3 are bonding These three are bonding. Lower energy occupied molecular orbitals are bonding. Higher energy occupied molecular orbitals are anti-bonding. This is the energy level. So these are bonding, those are anti-bonding. Now we have to shade these orbitals as our previous example 1,3 butadiene. So how we have to shade? So to shade these orbitals, to make them bonding or anti-bonding, we have a shortcut that we have to remember that nodes. Psi1 0 node, Psi2 1 node, Psi3 2 nodes, Psi4 3 nodes, Psi5 4 nodes, Psi6 5 nodes. If we can able to differentiate with these nodes, we can easily understand the molecular orbital theory for pi molecular orbitals. So now 0 nodes means all are same side positive. Always Psi1 is 0 node. Okay, so this is the Psi1 molecular orbital theory in 1,3, 5 hexatriene. Coming to Psi2, here we have to make one node. One node means let's take a center point. 3 orbitals are one side, 3 orbitals are another side. This is the center point. Now we are going to make a node. So these 3 are upside positive nodes or shaded nodes. So these 3 are downside positive. So 3 carbons are upside, 3 carbons are downside. Now see, simply we can divide it into 2 parts. These are upside, these are downside. So here node will form. If we can cut here, there is no node. If we can cut here also, there is no node because of both are same. If we can cut at this place, so differentiation is there in between these two. So that node is formed. So one node is present. Only one node is present. So here 0 nodes, all are upside. Here 1 node. 3 are upside, 3 are downside. Next one is 2 nodes present. How we have to separate it? With the giving equal priority, we have to separate as 2 nodes here. See, I am separating here, here 1 node and here 1 node. 2 nodes in between these two, So I am giving positive charge upside or shaded side upside for these 2 orbitals, and then here 2 nodes downside, here 2 nodes, I mean shading upside 2. Now from these 2 differentiation is there, so node formed. From these 2 differentiation is there, node formed. So from these 2 there is no node, from these 2 there is no node, from among these between these 2 also there is no node. Between these 2 no node, between these 2 there is a node, between these 2 there is no node, between these 2 there is a node, between these 2 no node present. So 2 nodes are present. 2 are up, 2 are down, 2 are up. So node. 2 nodes are present. Now Psi4 having 3 nodes. How we count? We have to separate them. 3 nodes we have to give here with equal priority. So now how we can give? I am giving 1 node here. I am giving 1 more node here. I am giving one more node here. Check it. So now upside shaded, and these 2 are downside noded, these 2 are upside noded, and these 2 are downside noded. I mean shaded. Sorry, not noded, shaded. These 2 are shaded. Now I am separating 1 node here. There is no node in between these 2. and here node is present between C3 and C4. C4 and C5 there is no node. C5 and C6 there is a node, carbon atoms. C5 and 6 there is node. So 3 nodes are uniform. So here 1, 2 will be here, 2 will be here, and 1 will be there. This is a node, this is a node, and this is a node. 3 nodes are present. Fine, understand? So observe clearly and make every possibility to shade. So next one, 4 nodes. 4 nodes. How we have to give with uniform priority? Let me draw this. 4 nodes. 1 node. Sorry. Let me give 1, 2, 3, 4. No. 1, 2, 3, 4 also no. Let me give now nodes. 1, yes, 1, 2, 3 and 4. Super. Check. With uniformity. One node is present here. Another node from this C2 and C3 are there. In between C3 and C4 there is no node. There is no node. And in between C4, C4 and C5 there is a node. C5 and C6, between them are node present. So total nodes are 1, 2, 3, 4. Super. Means first one upper, down, 2 will be there, and down and up. Understand? So now 1 node, 2 nodes, 3 nodes, and 4 nodes are there. Next step, 6th one, 5 nodes should be there. Here very very easy. First one and 6th one are very easy. See, upside. All are opposite. All are opposite. 1 node, 2 nodes, 3 nodes, 4 nodes, 5 nodes. All are opposite. So 5 nodes are there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 nodes are there. Clear? Clear? Now. So this is one point of way we found that nodes, how many nodes are present in each and every pi molecular orbital in 1, 3, 5 hexatriene. Now we have to check symmetry of these molecules. Symmetry of these molecules. What is the symmetry? As I said, if we can cut these molecule into 2 parts by taking any point, maximum taking center point, if it divided into 2 opposite parts, that make symmetry. If both are same, if we divide into 2 parts, if both are same, means that if they show mirror image, there is no symmetry. Now coming to psi 1, if you can cut from here, these 3 are same, these 3 are same. So this is symmetric. Psi 1 is symmetric. Coming to psi 2, this is unsymmetric. Upside 3, downside 3. See, means opposition is there. So this is not mirror image. When we keep a plane in between these 3 and these 3, there is no mirror image. So that it creates unsymmetric unsymmetric nature. Unsymmetric. Coming to psi 3. Psi 3. We can cut from here these three. These three, both are same. See, mirror plane is visual in here. These three are same and these three are same. So this is symmetric. Next one is simply unsymmetric. Next one, symmetric. Observe, you have to observe. So next one is completely unsymmetric. Unsymmetric, right? Now let's see the electronic configuration for this molecule. Electronic configuration. 6 unhybridized p orbitals are there. Those 6 p orbitals are having one electron on each of them. So totally 6 electrons are there. Those 6 electrons will be filled as, so very lower energy first occupies with 2 electrons, means psi 1 having 2 electrons, less than psi 2. Psi 2 also will get or occupies with 2 electrons, and remaining 2 electrons will be there in psi 3. Next, psi 4 having 0 electrons, this is anti-bonding. Psi 5 also having 0 electrons, and psi 6 also having 0 electrons. This is the electronic configuration for this molecule. Now, let me tell you which one is HOMO and which one is LUMO orbital in this. See, HOMO, LUMO. This orbital, psi 1 is occupied with 2 electrons, psi 2 also occupied with 2 electrons, psi 3 also occupied with 2 electrons. Coming to psi 4 and psi 5, psi 6, there are no more occupied electrons. Means that I am giving psi 3 HOMO. Means that here 3 orbitals are occupied with electrons. Among these 3 orbitals, psi 3 is the highest occupied energy. This is the lowest occupied energy. This is the next level occupied energy. This is the highest energy occupied with electrons. In terms of electrons we are talking. Here, in psi 1 electrons are there, in psi 2 electrons are there, in psi 3 also electrons are there. But psi 3 is the highest energy with occupation. So this is having electrons, occupied with electrons. Next, psi 4, there are no electrons. This is unoccupied orbital. So this is the highest energy with occupied electrons, means highest occupied molecular orbital. HOMO means highest occupied molecular orbital. Next one, this one is LUMO, means that this is the highest energy, this is the next highest energy, this is the next highest energy. But come among these 3, psi 4 is the lowest energy with no electrons. In the psi 4 no electrons, psi 5 also no electrons, psi 6 also no electrons. But compared to these 3, psi 4 is the lowest energy. Fine. That's why psi 4 is lowest unoccupied molecular orbital. Clear? So this is the highest unoccupied molecular orbital. This is the lowest occupied molecular orbital. But these two are enough to understand for us in terms of examination and in terms of objective bits. But mostly they don't care about these two, but these two should be mandatory. So remember these two: highest molecular orbital, lowest unoccupied molecular, highest occupied molecular orbital, lowest unoccupied molecular. Fine. So I think all points I have covered. If you write as it is in the examination, you will get definitely out of marks. This is HOMO. And this is LUMO. Fine. Clear. If you can able to understand this example, you can easily draw benzene molecular orbital diagram. Benzene pi molecular orbital diagram. So remember this. This is C1, C2, C3, C4, C5 and C6. Now by using this example, I am going to explain you benzene. I am going to explain you benzene. Benzene is this is the benzene structure. 6 carbon atoms are having 6 unhybridized p orbitals in benzene also, but this is linear structure 1, 3, 5 hexatriene, but benzene is the cyclic structure. That is the difference. So here also 6 carbon atoms are having 6 unhybridized p orbitals, and that 6 unhybridized p orbitals will be able to form pi bonds. So 3 pi bonds also will be present in benzene. Now how we have to connect them by using this example? I am simply telling you that means that we have to give the shaded or positive sides to these lobes. So to give this shading, so if we can understand this structure, easily we can draw for benzene also. That's what I am telling. So now Psi1. So I am connecting C1 with C6. C1 with C6. See. Benzene. Here I am taking C1. This is C2. This is C3. This is C4. This is C5. And this one is C6. So now I am giving shading. C1 all are upside shaded. In C1 all are upside shaded. In C2 this is C1, Psi2. This is C1, C2, C6. C1, C6. Clear? Now 3 are upside, and C1, C2 and C3 are the upside shaded. C1, C2, C3 are the upside shaded. Next 3 bottom shaded. Bottom shaded. This is Psi2. Coming to Psi3. C1, C2, C3, C4, C5 and C6. Psi3 will be C1 and C2 are upside. C3, C4 are downside. C5 and C6 are upside. Fine. Next, Psi4. Psi4. C1, C2, C3, C4, C5, C6. C1 upside, C2 downside, C3 downside, C4 upside, C5 upside, C6 downside. Super. Next psi5. C1, C2, C3, C4, C5, C6. C1 upside, C2 downside, C3 upside, C4 also upside, C5 downside, and C6 upside. C6 upside. Next, psi6. C1, C2, C3, C4, C5 and C6. All are opposite. C1 is up, C2 is down, C3 is up, C4 is down, C5 is up and C6 is down. Clear? If you can understand this, you can easily draw the benzene molecular orbital diagram. So for your understanding purpose only, I'm telling comparison. Now let's compare this 1, 3, 5 hexatriene with benzene. So by using this example, we are going to shade the benzene molecular orbitals and we are going to cut them with respect to nodes. See, if you can cut from here or here, from here, we are not able to differentiate both of them with respect to any axis, or with respect to this axis also we are not able to cut them into two. So here 0 nodes. Psi1 has 0 nodes. Coming to Psi2 we are going to cut with this axis. See, this is different, this is different. So both of them are opposite. So we are easily cut this with respect to this axis. If we try to cut with this another axis, we are not able to cut because both are same. If we can use this axis also, these two are same, we cannot cut. If we can use this plane also, both are same, upside. So with respect to any plane of axis, we are not even able to cut them into two parts except this one axis. So one nodal plane is there, one node present. So coming to Psi3. If we use this axis, we cannot able to divide them into two parts. If we use this axis, even also we cannot able to divide this into two halves. If we cut with this respect to this axis, even though we are not able to cut them into two different parts. If we can use this axis, we can able to cut this molecule into two parts. This molecule. See, both upsides are shaded, C1 and C6. Downside C4, C3, C4 are different. So with this plane of axis, we can able to divide them into two parts. Here also, with respect to one nodal plane, we are able to cut this into two halves. So Psi1 is 0 nodes, Psi2 and Psi3 are both are same in energy level because they are having one node each other. So these are bonding molecular orbitals because 3 are bonding, 3 are anti-bonding now. So coming to Psi4, with respect to this axis, we are able to cut it into two parts, right? And then if we use this axis, even we are able to cut it into two parts because there are C1 upside and C4 downside shaded. C6, C4, sorry, C1, C3 different, C4, C6 are different. So we can easily cut them into two parts. So with respect to two nodal planes, two nodal plane of axis, we are able to separate them. So two nodes are present for psi 4 molecular orbital. Coming to psi 5, by using this plane we cannot able to cut into two parts because same. By using this one also we cannot able to, we can able to cut it into two parts because this is upside and this one is downside, both are different, here both are different, so we can easily cut this into two parts with respect to this axis, and with respect to this axis also we can easily cut it into two parts, different. Fine. So here also two nodes. With respect to two nodal planes, we can easily separate into two different parts of psi 5 molecular orbital. Coming to psi 6, we can cut it into any way. With respect to all axes, we can easily cut them into three nodes. So three nodes are there. Now, if we are able to understand up to this level, now I am going to draw molecular orbital diagram for benzene. This all theory I have explained only for your understanding purpose. Now we are going to enter in real world. See how we have to write exactly in the exam point of view. I am going to show you. So now I am going to erase it. Psi 1 very ground level with respect to nodal planes, nodes. So psi 1, C1, C2, C3, C4, C5 and C6 all are upside. And then, so now I am giving very lower level for this psi 1 molecular orbital, and coming to psi 2. Psi 1, C1, C2 and C3 are upside, C4, C5 and C6 are downside. And then this is having one node, psi 2, and psi 3 also having one node. That's why these two are in equal amount of energy. So two degenerated parts. These two are two degenerated molecular orbitals. So they are having same energy. Psi 1 and psi 2, psi 2 and psi 3 are having same energy. So I am writing in this manner. They are equal. For psi 3, C1, C2, so this is with respect to this axis separated, this is with respect to this axis separated. So one node, 0 nodes. So that second level, psi 2, psi 3. 3 are bonding, remaining 3. Psi 4. Psi 4 can able to separate with two respective nodal planes, and psi 5 also. And psi 5 also. Psi 4, C1 upside, C2 downside, C3 downside, C4 upside, C5 upside, C6 downside. With respect to this axis and with respect to this axis, we are going to separate into two parts. Coming to psi 5, C1 upside, C2 downside, C3 and C4 upside, C6 and downside. We are going to cut this into two parts with this one. So, two nodes, both are same in energy level, psi 4 and psi 5. Next, coming to C6, will occupies highest energy than psi 1, psi 2, psi 3, psi 4 and psi 5. So C1, C2, C4, C5, all are opposite. C6, C5, C6. So we can cut into this one, and this one. Meaning with respect to three axes, we can able to separate it into different parts. So that three nodes are present. Three nodes are present. So psi 1, psi 2, psi 3, psi 4, psi 6. These are anti-bonding. These are bonding. This is no need. For your understanding purpose only, I have explained. If you will get confusion, you can write with this fashion in terms of rough in last pages of your examination paper. And if you want to write originally, you have to write this one for your exam purpose, because for this diagram only they will give the marks. Now we have to write, see, how many electrons are there? 6 electrons are there. 6 pi electrons are there. Those 6 will be in psi 1 electronic configuration. Coming to electronic configuration, psi 1 will occupies with 2 electrons, less than psi 2 is equals to psi 3. Both of them will occupies with 2 electrons, less than psi 4 is equals to psi 5. They are anti-bonding, so I am giving star marks, and 0 electrons are there, less than psi 6 anti-bonding, 0 electrons are there. Understand what I mean? So now psi 1, psi 2 and psi 3 will occupies psi 4 and psi 5, 0 electrons, and then psi 6, 0 electrons are there. Fine. Now let me tell you which orbital is HOMO, which orbital is LUMO. So in this case, psi 1, psi 2, psi 3 are occupied with electrons. Psi 4, psi 5, psi 6 are not occupied with electrons, unoccupied. These orbitals are unoccupied, these orbitals are occupied. In this occupied level, psi 2 and psi 3 are the highest energy compared to psi 1, because these two are in equal, so that we have to consider both of them equal. So psi 2, psi 3 are the HOMO orbitals, highest occupied molecular orbitals, and these two are the LUMO, lowest unoccupied molecular orbitals. And this is very much enough to get out of the marks in your exam.